Now I'll just shortly explain why these switches with the voltage and not the current or anything else. So this is a follow-up on my last video about how you make a bidirectional totem-pole PFC. So that gives kind of an introduction to this video. So the way we control the current is basically by controlling the voltage over the inductor. So in order to make the current rise, if the current rises, the voltage over the inductor is positive. And when the current falls, the voltage over the inductor is negative. And to make this controller good, we always want to be able to control the current up and down. So we always want VL to be able to be negative or positive. Now the constraint here is that the voltage VM, which is in the middle here, this is between VO, which is this one, and 0. So it cannot be negative. It can only be between those values. Now, if we just ignore these switches for a second, let's say that it always goes to 0, so this voltage is always 0 volts. So in that case, VM, which is this voltage, would always be between V0 and then and 0 volts. So the voltage over VL would be equal to VAC minus VM, as you see here. And we know that this one is always positive. It's always above 0. So this means that when VAC is a negative, which happens sometimes, then VL will always be negative. And this means that IL will always be falling. So therefore, we will not be able to make the current rise when the voltage is negative. So basically the controller wouldn't work if we didn't have the slow legs. But now let's say that we include the slow leg. So we control the slow leg such that this voltage here is controlled. We call it VSL for voltage slow leg, for the slow leg voltage. Now VSL is also the voltage here. So now the voltage at this point becomes equal to VAC plus VSL. Now, if we want to find VL, we can just say that VL is equal to VAC plus VSL, and then minus this voltage, which is called VM, so minus VM. Now, let's say, for instance, that VAC is negative. Then we can just switch this slow leg. So let's say that we turn on this switch here, such that VSL is equal to the output voltage. And the output voltage is greater than the AC peak of the AC voltage. So we apply a high positive voltage, which is always higher than the negative peak of VAC. So this also becomes positive. And now VM could be either 0 or VO. So when it's 0, VL is larger than 0, while when it's VO, it's equal to VO, then it's less than 0, because VO is a large number. So that is why we switch with the voltage. So when VAC is negative, we switch the slow leg such that this voltage becomes positive. And then when it's positive, we just don't do anything. We just switch this MOSFET such that the current flows through here instead, so that this is still positive, but it's not too high. Because if we still had this one on, the voltage here would be too high positive, such that this voltage, such that one could never make it less than 0 again. I know this became a little bit messy on the end here, but I hope it made sense. So the simulation model is in the description if you want to have a look at that.